This is the force and motion test. After each question is read, please pause the video and take your time to do your very best to choose the best answer. If at any time you need to pause the video and re-listen to a question, please do so. Number 1. Look at the diagram. Air resistance is pushing up at 625 newtons and gravity is pulling down at 705 newtons on the parachutist. Calculate the net force of the skydiver. Question number 2. Is the person in motion? If so, identify the direction of the motion. Question number 3. Look at the diagram. Notice the forces of the dogs in the sled team. Calculate the net force of the dog sled. Question number 4. What would happen to the motion of the sled if 2 large dogs were hooked up to the back of the sled and pulled with 250 newtons of force in the opposite direction that the sled is currently moving? A. The sled would continue to move forward in its current direction. B. The sled would stop moving and then stay in one place. Or C. The sled would change directions and move backwards. Number 5. A tire hanging from a tree is at rest. The force of gravity is pulling down on the tire. Another force called tension is pulling up on the tire. Tension is the pulling force that is transferred along with the length of the string or rope. If the force of tension is equal to the force of gravity, then what will happen to the tire? A. The tire will accelerate upward. B. The tire will accelerate towards the ground. C. The tire will remain at rest. Or D. The tire will swing towards the left. Number 6. With a force of 5 newtons, Amanda pushes the stack of books to the right. At the same time, Jeremy, her little brother, pushes the stack of books to the left with a force of 10 newtons. What is the direction and magnitude of the resulting force? A. 10 newtons to the right. B. 5 newtons to the left. C. 10 newtons to the left. Or D. 5 newtons to the right. Number 7. What is the unit for force? A. Liters. B. Kilograms. C. Meters. Or D. Newtons. Numbers 8, 9, and 10 are matching. Your choices are A. Stored energy due to shape. B. Energy of motion. C. Stored energy due to height. Number 8. Kinetic energy. Which of the descriptions matches correctly with kinetic energy? Number 9. Gravitational potential energy. Number 10. Elastic potential energy. Number 11. There is a skier at the top of a ski slope. The skier has potential energy. What gives the skier his potential energy? A. His efficiency. B. His speed. C. Friction. Or D. Gravity. Number 12. Pablo is sledding down a very steep hill. At which point in his trip does he have the greatest amount of kinetic energy? Circle your answer, A, B, C, or D. Number 13, which of the following would have the most potential energy? A car moving along a flat road at 60 miles per hour. B, a ball rolling on a flat surface. C, a rock sitting on the edge of a cliff. Or D, a roller coaster that is at the bottom of a hill. Question number 14. A diagram of a roller coaster track is shown below. Circle the location on the track where the roller coaster car has almost equal amounts of potential and kinetic energy. Number 15. Jim is carrying a box across the room. A. Add an arrow labeled force to show the force that Jim is applying to the box. Draw the arrow on your test and label it force. B. Add an arrow labeled motion to show the motion of the box. Again, draw an arrow on your test and label it motion. C. Is Jim performing work on the box? Explain. Number 16. Jack moves 10 cinder blocks every 5 minutes. Julio moves 12 cinder blocks every 5 minutes. Who is using more power? Explain. For numbers 17 and 18, you have 4 choices. A is an ice cream cone converting into the running person. B is a can of gasoline converting into a moving car. C is sunlight turning into the plant. And D is an electrical cord and a power outlet converting energy into the oven. Question number 17. Which illustration shows chemical energy being transformed into kinetic energy? Number 18. Which of the diagrams shows electrical energy being converted into heat? Question number 19. Mark each statement that is true about conservation of energy when a wrecking ball is swung. The bricks transferred kinetic energy to the wrecking ball. The wrecking ball transferred kinetic energy to the wall. Kinetic energy from the wrecking ball is transformed into gravity. Kinetic energy from the wrecking ball is transformed into heat. Kinetic energy from the wrecking ball is transformed into light. Kinetic energy from the wrecking ball is transformed into sound. Question number 20. Was any energy created or destroyed when the wrecking ball hit the brick wall? Take some time to look over your test, make sure that you have answered all of the questions and that you like all of the answers that you have chosen. If there is a question that you would like to have reread, either rewind back to that part of the video and listen to it again, or raise your hand and I will come and read it aloud to you.